Welcome to the DIY Honda Garage channel. The DTC code P24BD-16 refers to a diagnostic trouble code specifically indicating a low voltage issue within the canister changeover valve control circuit. This error code is significant because it affects the functionality of the canister changeover valve, CCV, which is crucial for managing fuel evaporation and maintaining emissions control. The Powertrain Control Module, PCM, monitors this circuit and registers an error when it detects a return signal from the canister that is inconsistent with its commands. In essence, the PCM determines that there is an abnormality if the CCV signal is closed when the PCM is not in the process of sending a closed signal to it. The location of the canister changeover valve is integrated with the EVAP leak check module, which is generally located in the vehicle's rear section, near the fuel tank. The PCM, which is essential for controlling engine functions and emission systems, is typically found within the engine compartment. The error code P24BD-16 is associated with the canister changeover valve, CCV, and the Powertrain Control Module, PCM. The CCV plays a vital role in the vehicle's evaporative emissions control system, directing fuel vapor to either the engine or the charcoal canister depending on the engine's needs. The PCM monitors the CCV to ensure it operates correctly. If it detects an anomaly such as low voltage in the control circuit, it triggers the DTC. The CCV is integrated within the EVAP leak check module, which is positioned toward the back of the Honda CR-V, usually near the fuel tank. Understanding these components' placement and roles is crucial for effective troubleshooting, as they interact to maintain both vehicle performance and compliance with emissions requirements. Several possible causes can lead to the DTC P24BD-16, each requiring thorough investigation. First, a low power supply to the CCV or its circuit can trigger this error, suggesting an electrical issue impacting its operation. Wiring issues may also be present, such as open circuits or shorted connections that interrupt correct signal transmission. Another possibility is a faulty EVAP leak check module. Since the CCV is integrated into this module, its performance is directly linked. Lastly, if other components check out fine, the PCM itself could be malfunctioning, necessitating further inspection and diagnosis. Each potential cause should be verified through systematic testing, as outlined in the diagnostic guide, to ensure accurate repairs. When the DTC P24BD-16 is triggered, several symptoms may emerge, significantly influencing vehicle performance and compliance. The most immediate indicator is the illumination of the check engine light, alerting the driver to a potential issue that requires attention. Additionally, the low voltage problem can lead to poor fuel efficiency, as the vehicle's evaporative control system may not function optimally, allowing fuel vapors to escape rather than be recaptured and utilized. This dysfunction can also result in potential emissions failures during testing, as the vehicle may exceed acceptable limits. Addressing these symptoms promptly is crucial, not only for vehicle performance, but also to avoid legal ramifications associated with emissions regulations. The first troubleshooting step requires the technician to turn the vehicle to the on mode without starting the engine. This step allows the vehicle's onboard diagnostic systems to power up and communicate effectively with the Honda Diagnostic System, HDS. Next, perform the EVAP leak check module test using the HDS. This test checks for abnormalities in the EVAP system, specifically the leak check module's functionality. If the test results indicate a failure, it confirms that the issue lies within the EVAP subsystem, necessitating further exploration of individual components, such as the CCV, wiring, or PCM. Document the outcomes of this test before proceeding, as it sets the foundation for the subsequent diagnostic processes. In the second troubleshooting step, focus on the IGPS intake gas pouch system circuit to verify its performance under specific conditions. Begin by disconnecting the EVAP leak check module connector, which typically has 8 pins. This step is critical to isolate the circuit for accurate testing. Next, check the power supply to the IGPS circuit by ensuring the vehicle is in the on mode and measuring if it returns 12 volts from the battery. This voltage reading is crucial because it indicates that power is correctly flowing to the canister changeover valve system. If the results show unusual voltage levels, it suggests a potential problem in the supply chain, warranting further inspection of wiring and connections to diagnose the root cause correctly. The third step involves disconnecting the PCM, Powertrain Control Module, Connector A, which usually features 72 pins, in order to examine the CCV circuit. Prior to disconnecting, jump the SCS, Service Check Signal, line with the HDS to prepare the PCM for diagnostics. It is essential to wait for over 1 minute after this step to ensure the system stabilizes. Once the PCM is disconnected, inspect the CCV open wire condition to determine if it meets the threshold of less than 1 ohm for continuity, which indicates a properly functioning wire. Following this, check whether the CCV is shorted to ground, ensuring it exceeds 1 megaohm. Any abnormalities at this stage signal a potential fault in the wiring or CCV that needs addressing. In this step, replace the potentially faulty EVAP leak check module with a known good component to confirm its functionality. Given that there isn't a direct testing method for the EVAP leak check module, using a known good part allows the technician to replicate the scenario without bias. After installation, retest the system to see if the original problem persists. If the failure is reproduced, the issue lies within other associated components in the EVAP group, indicating a broader problem to be addressed. Conversely, if the DTC or symptom disappears, it confirms that the original EVAP leak check module was indeed faulty and will require replacement. Final step in troubleshooting revolves around the PCM if all previous inspections have returned valid results. If the IGPS circuit and CCV tests indicate proper function, it strongly suggests that the PCM may be at fault. Inspect the PCM for any visible signs of damage or corrosion, as such conditions can directly affect its performance. Additionally, utilize HDS to perform any further diagnostic checks specific to the PCM functionality. Should these inspections confirm an abnormality in the PCM's operations, it is warranted to proceed with replacing the faulty unit. This step ultimately ensures that the PCM is not the source of the canister change over valve circuit low voltage error, which improves overall vehicle performance and emissions compliance. After completing all repairs, it is essential to conduct a final verification process to ensure everything is functioning as intended. Start by clearing the DTC using the Auto Diagnostics system, HDS, to reset the vehicle's onboard diagnostic system. Following this, perform a test drive to observe if any check engine light re-illumination occurs and to assess vehicle performance during regular driving conditions. Pay close attention to any performance symptoms that were previously reported, especially concerning fuel efficiency and emissions functions. Only when the vehicle operates without triggering the DTC again can a technician confirm that the repair process has been successful. This last step is critical to validate that all underlying issues were adequately addressed. To prevent future occurrences of DTC P24BD-16, implement a routine maintenance schedule that includes regular emissions checks. These checks help ensure that all components of the EVAP system are functioning correctly and can prevent issues from escalating unnoticed. In addition, conducting periodic wiring inspections enables the identification of potential issues such as corrosion or wear before they become significant faults. Maintaining the integrity of electrical circuits is vital, as even minor connector issues can lead to DTCs. Lastly, keeping records of any repairs and service performed can provide insights into recurring problems, enabling proactive measures to be taken to safeguard the vehicle's emission systems effectively. The diagnostic process for the DTC P24BD-16 emphasizes the importance of a comprehensive approach to vehicle maintenance and repair. By understanding the roles and locations of critical components like the canister changeover valve, EVAP leak check module, and PCM, technicians can systematically isolate faults within the system. Identifying the signs and symptoms related to this DTC allows for prompt and effective intervention, reducing the risk of serious performance issues. Furthermore, following a rigorous troubleshooting protocol ensures that each potential cause is adequately examined, facilitating accurate repairs. As a result, drivers benefit from improved vehicle efficiency and compliance with strict emissions regulations, illustrating the importance of diligent diagnostic practices in maintaining modern vehicles like the Honda CR-V. Please like and subscribe to the channel. See you next time.